Okay, so in this video we are going to be talking about multiple representations of linear relationships. We're going to be doing two things with these notes. We are going to be recognizing and representing. On this first part, part one, on the front half of these notes, we are going to be recognizing. We are going to be learning how to tell if it's linear, and then we'll be learning how to tell if it's nonlinear. So, a relationship between two quantities that have a constant rate of change and a straight line graph is a linear relationship. So keep that in mind. The two characteristics that you need to look for if you're looking at a graph and you want to know if it's linear or not. First of all, most important that you got to look for, it must be a straight line. It just has to be. Linear has literally the word line in it, so your graph has got to be a straight line. Secondly, you might be wondering, well, what if it's proportional or non-proportional? Well, it could be either, meaning it goes through the origin or it does not go through the origin. Here I've highlighted the origin for you in red, and you notice that in this example, the line doesn't go through the origin, so that means this is a non-proportional linear relationship. But you can have a proportional linear relationship, meaning that it does go through the origin in some way. So don't worry too much about whether it's proportional or non-proportional. If you're looking at a graph and it's a straight line, you know that it's linear. If you're looking at a table, the thing you need to be on the lookout for is a constant rate of change. And we do that with some bunny hops. So you just hop, and notice I filled in this table here with 1, 2, 3, 4. I'll explain why I did that on the back side of this paper. But we just bunny hop from each of the x's, and we look at how does it change. Well, 1 plus 1 is 2, 2 plus 1 is 3, and 3 plus 3 is 4. Now don't forget to go down and look at your y's as well. So we bunny hop the y's. 10 plus 2 is 12, 12 plus 2 is 14, 14 plus 2 is 16. So as x increases by 1, y increases by 2. So we've got a constant rate of change there. It's changing at the same rate. It's always 2 over 1, 2, 1, 2, 1. So our rate of change is constant. Now if you have an equation, that's pretty simple. You look and see and make sure that it has no exponents, meaning we don't want to see anything like x to the second power or x to the third power. Anything that's got an exponent in it in the equation is not linear. So just look at your x and see, does it have a little superscript up here that has 2 or 3? And this one doesn't, so we know that it is a linear equation. Now, how do we tell if it is not linear, if it is non-linear? Non meaning not, and of course linear meaning a line. Well, first of all, there will be no constant rate of change, and it will have a curved line graph. So when you're looking at a graph, that's pretty easy. I mean, look at this thing. This is called a parabola. You don't have to remember that. You'll learn about these when you get into algebra, either as an 8th grader or as a 9th grader. But the main thing here is you need to see this is not straight. Not straight, not linear. It's also not proportional. It doesn't go through the origin there. But again, we're not quite so concerned with whether or not it's proportional. When we're looking at this, we see it's not straight, so it's not linear. That's what we care about. We're trying to recognize here. Now look at the table, and again you'll see I have filled in 1, 2, 3, and 4, and then for the y's I put 2, 4, 8, and 16. And I did my bunny hops, hop, 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 and I see that 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4. Down below on the y's, and yeah, you have to look at both, did my bunny hops, 2 plus 2 is 4, 4 plus 4 is 8, and 8 plus 8 is 16. This is not a constant rate. It's different each time. This first one is 2 over 1. Then we have 4 over 1. Then we have 8 over 1 for the rate of change. Not constant, not linear. Now look at the equation. If you remember from above when we talked about linear, we said that it can't have exponents. Well, Right here, we see that the x is to the second power. That's an exponent. It has exponents. That means that this is non-linear. Okay, so down below here, and I think I just might have shown you the answers, I want you to determine whether the relationship in each table represents linear relationship. You can pause the video and come back in a minute and I will show you the answers. Go ahead and do that now. Okay, so we're going to recognize these tables as either linear or nonlinear. So I did my bunny hops on the first table, and I see that it's +2, +2, +2. Then on the y values, I did my bunny hops, and I see it's +2, +2, +2. It's the same each time, so that means this is a table that represents a linear relationship. Now, over here, I did my bunny hops, and for the x values, I see I have +1, +1, +1. Then for my y values, I see that it is +4, +8, +16. The values are different each time. Here I have 4/1, then 8/1, then 16/1. So the rate of change is different each time. So that means that this is a non-linear relationship that's being represented by this table. All right, so that is the recognize portion. That's part 1. Now we're going to go to the flip side, and I will talk about representing.